recording, and the speech will be recording now, and it will be available for the persons who are not present in this session. So, Dr. Geissen, the time is yours, and we are listening your presentation. Thank you.
Yeah, Masoud, thank you very much for this introduction, and thank you very much for this invitation. It's a great pleasure for me to give you this presentation today. So I was introduced by Masoud already. I have to add that we have another project running in Iran together with Qatar University, which is dealing with brackish water desalination for irrigation applications in agriculture in the southeastern part of Iran. And it, as I mentioned already, with Qatar in the field of aquaponic. So, but nevertheless, today's topic is industrial water management, and I'm working in this field for more than 25 years. It's a highly relevant topic, and therefore Masoud asked me to give an introduction into this topic. Yeah, my presentation is divided into 4 parts. I will give you a short introduction, then I will move into examples, followed by implementation, and last but not least, I will finish my presentation with some trends. And starting with the introduction, I just like to, I think it's obvious why should we move into water recycling? It's very clear. Lack of water. Without water, no production. Without water, no life. We can say it in a general way, but in the context of industry, without water, no industry, no industrial production. And this happens from time to time, not only Iran, but also in Spain, where companies like PVC production had to drop down their production. And if we are moving into this field, it becomes highly costly. So therefore, one of the greatest motivations for sure is the availability of water, not only with respect to quantity, but also with respect to quality. And here's a case shown in a water-rich, it seems to be a water-rich region. It's the Netherlands. It's a Doe location, Doe Terneuzen. We can see here in the background, you can see the community. Here, that's Terneuzen, that's the city of Terneuzen, and that's the Doe site here. And they have, limited availability to fresh water. Why? This is Schelde River here. It's brackish water. And they have, first of all, the challenge with respect to the salt concentration. And secondly, they are not allowed to take huge amount of water out of the Schelde River. So it's also in Europe. It's happening the same. I can give you another example. It's the northern part of Germany, in nearby Bremen or nearby Hamburg. For those of you who know Germany, it's in the northern part of Germany, near to the North Sea, where a municipal wastewater treatment plant finished their construction for reusing water, 900,000 cubic meters per year for industrial applications. So it's already, this water reuse, this water recycling is already implemented even in Germany, Middle Europe. No, it's not only a question of water scarce regions, traditional water scarce region like Jordan, like the MENA region in general, like Iran. It's also a question in the middle of Europe. So coming to the basic question, what are the motivations for investment? As I mentioned already, general water demand, without water, no production. That's very obvious, very clear. We have some priorities of today, which are the economics. You need a certain time return of investment. So that's depending on the companies, how they are calculating, whether it's 4 years. I also have been involved in projects where it's only 1 year return of investment. So that's the driver at the moment. The energy efficiency in Germany, at least, in Iran it's a different situation, but in Germany it's a very strong driver because the energy prices are very high. We have to pay about, let's say, between 15, depending a little bit on the industry, between around, let's say, as a mean value, maybe 15 euro cents per kilowatt hour electrical the price for electrical energy. So energy efficiency is a driver. We have then additionally the regulations, and this is a very strong driver. We have the European Wastewater Framework Directive. As you might know or might not know, I don't know, is we have in Europe, we have the situation that we have the European, let's say, legislation, which is releasing directives. These directives are for the industry in the member countries not legally binding directly. So they have to be transferred into national law. And after this, they are legally binding. So therefore, what I'm talking about is a Water Framework Directive, which was released 20 years ago or 15 years ago. And this is now on the way to be implemented into different member countries of European Union. And this is a very strong tool in order to protect the environment, in particular, the aquatic environment. Why? Because we are moving into a situation where we do not have, let's say, emission standards like a COD in milligram per liter, which actually is in Germany for municipal wastewater treatment around 60 milligrams per liter, depending on the size. So 60 milligrams per liter, no. We are moving into a legislation where the quality of the receiving water body is in the focus. So what is the quality of the river where I'm discharging my effluents? And this is finally giving then or resulting in the effluent standards which have to be reached. So it's another approach in order to improve the quality of the environment or to improve the standards of environment. We have also we see also stronger laws in in China, for example, but in other countries, other nations also. In Brazil, it's starting to get more stringent. These are the drivers of today. In future, and future is already today, partly, we have recovery of valuables in energy. So it's a very strong driver. So valuables are in the wastewater, and energy additionally, because industrial effluents usually have a high temperature, depending a little bit, looking at the beverage industry, we have a temperature of 35 degrees, roughly speaking, or approximately temperature in the effluent of the wastewater effluent. And this is energy, which is very, very important, because you have to heat up water. And you can make a simple balance. Might be that maybe it's clear for you that heating up water is extremely energy intensive. So therefore, recycling of water means also recycling of heat energy. And this another point is sustainability green labeling. That's a very strong force at the moment. That means why? Because the companies who are producing goods have to fulfill certain standards with respect to carbon dioxide emissions, but also with respect in general with respect to sustainability. And water treatment, water use, water recycling is also an aspect of sustainability and green labeling. And last but not least, we have seen worldwide cases where industrial activities have to be stopped because of lack of water availability or from one day to another changes in the legislation with respect to wastewater discharges. In India, for example, it happened that companies had to close their facilities from one day to another, more or less. So, and therefore, companies are very much interested in to become independent on water supply and decisions which are made outside the companies with respect to water availability, but also with respect to water prices. And these are trends which are already nowadays existing. And finally, what is important, the integrated sustainable water management and recycling. So looking at the waters in this industrial water cycle, we are starting with raw water, which has to be treated. So most of the industrial water is treated before it's used. Looking, for example, at the boiler feed water, because the heat in industry is basically a steam, and therefore we need boiler feed water. Boiler feed water has to have a certain conductivity, which is quite low, in order to prevent scaling in the boilers. So therefore, raw water has to be treated. Iron has to be removed if present. Manganese has to be removed if present. Suspended solids have to be removed. Hardness builders like calcium, magnesium have to be removed, etc., etc. This is something which have to be kept in mind, because this is also a question of costs finally. The pre-treatment or the treatment of the raw water in order to produce process water which can be applied in industry. Yeah, then the industrial process takes place, independent whether it's steel industry, it's a refinery, it's food industry, whatever. All of them are releasing substance. They are using water. Therefore, it's not wastewater. It's not water consumption. It's also a very important note. Usually, we do not consume water. You, the person, also not. Me too. I'm taking the water from the tap for example, for cleaning, for taking a shower. I'm taking the water from the tap in order to prepare my food. I'm taking the water from the tap in order to flush my toilet, in Germany at least. And this finally means we do not consume water. We are using water. So finally, the water is more or less quantitatively released into the sewage system in the best case, or in the environment finally. So that means we are just using the water. We have evaporation for sure. So for example, if we are using for cooling, and we have evaporation cooling, like this is in Isfahan, in the power station Isfahan, for example, the water is used for cooling, and therefore you're evaporating water. This water is consumed, it's gone into the atmosphere finally, so that's gone. But most of the water finally is released wastewater. That's something which we have to keep in mind. And additionally, all of the most of the substances which are used in the industrial process are finally ending up in the wastewater. Additionally, and we have the wastewater treatment. In the best case, and the water is released to the surface water. And this can be, as it means it's the environment in general, so the water afterwards is feeding the groundwater or whatever, and it can be used again as water for industrial processes. So we have alternative water resources, which is, for example, municipal wastewater. I already mentioned an example, and in Isfahan there are also examples for reuse, starting of reuse of municipal wastewater or municipal effluents in order to produce process water for industry. We have rainwater, which can be collected. Frankly speaking, that's only a small part of water which can be utilized, even in Germany. So the airport in Frankfurt is utilizing rainwater. Audi, the company, the car manufacturer, Audi in Ingolstadt is using rainwater. But frankly speaking, it's only a small portion of the water which is required by the industry. But nevertheless, it's an additional water resource. Yeah, and then we can also talk about recycling. So wastewater, why not recycling directly in industry? It has certain advantages because when we are talking about recycling, it's easy to say. So we have the technologies, I will introduce to you to the technologies, but that's only part of the story. The second part is, and I would say the same, the second part is the logistics of the water. Now you have to keep in mind, producing wastewater or the quantity of wastewater is not balanced. It's not all over the day the same. So for example, if we are looking at municipal wastewater, we have strong fluctuations during the day. So in the morning, everyone is preparing the breakfast, is taking a shower, cleaning, etc., etc. So we have a lot of effluent in the morning. Then it's dropping down a little bit. Then it's increasing slightly to midday, and then it's dropping down again. Then we have an increase again when people are returning back from work. We have an increase, and then we have more or less no municipal wastewater no raw wastewater in the nighttime. Not because no one is using water in the nighttime. We are sleeping, basically, very simply speaking. So there is no wastewater. That's what I mean with logistics. No? So we have to have buffers in between. So we can take the effluents from industry. It's the same situation. So we have production processes which are not balanced out over the week. Now, so we have fluctuations also during the week. We have fluctuations during the day. So we have fluctuations during the hour, for example. So we have to have buffers. That's one challenge. And secondly, we have to have transport function. So we have to transport the water after treatment from one place to another. And this is a challenge. It's also a technical challenge, but we are always focusing on membrane processes and biological processes and adsorption and extraction and so on. But the logistics, in most cases, we forget. So it's very, very important to have this in mind, that we have this transportation, the storage, all these things which we have, the handling of the water after treatment. So producing water out of effluent is not a challenge. You can do it. It's just a question of costs. But finally, we have to store it somewhere and we have to transport it. And then the question with microbiological contamination comes into the game. Because in particular, you have also high temperatures in Isfahan, V2 nowadays in summers in Germany, Middle Europe. We have also up to 30, 50, 40 degrees. And this is the best temperature for the growth of microbes. So therefore, we have to look for disinfection additionally in these recycling systems. So this is some words. So take it into consideration. It's not only technology, it's also the logistics behind water recycling, which is of importance. And additionally, what I personally prefer very much to go into the production facilities to look where is a direct recycling possible. Not end of the pipe after wastewater treatment, no, directly in the process. So we have many opportunities in the processes, which might be not far away from each other, where you can downcycle the water, which is done, for example, in beverage industry. When you're producing, in Germany, we have a return bottle system. So when we are purchasing a bottle of beverage, we are purchasing them in bottles, and these bottles are returned finally to the dealer. And the dealers are returning the bottles back to the industry. So these bottles are washed. And this washing machine is counter current flow. So the bottles are moving in one direction and the water is moving in the other direction. That means finally the more or less clean bottles are in contact with the high quality water. And the contaminated also, that means the dirty bottles are in contact with the contaminated water. So therefore we have a counter current, we have a downcycling of the water more or less, and we have an additional use of the water. Formerly, at different places, always fresh water has been used. So this is one example of many other examples. So go into the industrial processes, look what possibilities you have. And this is something I mentioned partly already. So we have to look to the contents of water. So we are always talking about wastewater. Yeah, it's wastewater, but it contains basically looking in the top of water. We have organics in the water. We have the inorganics, that means salts and metals. We have the heat energy, and we have the water by itself. So basically, we are interested in the water. But nevertheless, we should be also interested in the heat energy. And this is one thing which we have to take in consideration additionally. I will give you some examples on this later on. So the question is, what will be the future for industrial processes? And I would like to show you a publication, which is now from 2004. It's not a very new publication, but nevertheless, what I have also read from United Nations, the estimations worldwide with respect to industry are already the same. They are predicting an increase in water use or the water abstraction. And this is the same here for this publication, manufacturing 30% increase from 2000 to 2030. And this was in Northern Europe and even in Southern Europe, 24% increase. Doesn't matter, the numbers is not so important, but just the message is all of the predictions indicate that we will have an increase in water use worldwide. That was predicted for Northern Europe and Southern Europe. So the reason is high quality products require higher water demand. Yeah, but generally the question is, what is German experience? And German experience is different. So we have, it's a very old example, but nevertheless, it's history. Let's say it like this, it's history. And this is for pulp and paper industry. Now, going back to the year 1974 in Germany, this German paper factories. No? So we're looking at the wastewater production in liter per kilogram of paper produced. There's a paper machine at the right-hand side here, upper right-hand side. So how much water is used to produce 1 kilogram of paper? And it was about 50 liter of wastewater, which was produced per kilogram of paper in 1974. And what you can see here in this diagram, until the year 2001, we have had an decrease of, let's say, roughly 80% of wastewater production from paper industry. Specifically, no? Not absolutely specific numbers, liter per kilogram or cubic meter per ton. So now as a mean value, we can in 2001, and nowadays it's more or less the same range, maybe it's 8, but this is the range, liter per kilogram, liter of wastewater per kilogram of paper. So we have a dramatic decrease of water use. And what is the reason finally for it? Now the question in this years, we haven't had water recycling facilities. We haven't had membranes available. Now this is something we have to keep in mind. It just by improving the production process and increasing the awareness. That's very important. So people, same I observed in Isfahan when I moved to a park, when I walked through a park in Isfahan city. I've seen the water hose lying at the bottom and flushing huge amounts of water through the greens, and it's flowing off as a runoff over the surface onto the street. No, so the awareness is not there, and this is most important, that people are recognizing that water has a value. Water is limited. Yeah, and we need water, and this is something which has to be. I know this takes generations, but nevertheless, it's a must that people are aware that water is scarce and water has a value. And this is something. These are the two effects. So better production machines, or more efficient production machines, production processes, and additionally awareness. I've made the same experience when I moved into these industrial facilities many times. I'm always, even nowadays, I can observe possibilities to save water. Very simple ones, partly. So therefore, do it. Just do it. That's my recommendation. So that was paper industry. This is another example from steel industry. Specific water use, cubic meter per ton of raw steel. So it's dropped down, even though in Isfahan the numbers are lower, but nevertheless, for me the absolute number is not so important. It's just the possibility to reduce the water demand. So when we are talking about water water use, we have to ask the question, what should be the quality of the raw water, or what should be the quality of the processed water which we are using in industrial processes? So we're starting with raw water. We can utilize different kind of raw water. So that might be surface water, that might be groundwater, that might be tap water, and that might be, as already mentioned, alternative water resources, processed wastewater, rainwater, municipal wastewater. Now, all these kind of raw water resources are utilized and we can utilize. And yeah, these are the technologies I mentioned already to remove manganese, to remove iron, to remove suspended solids, etc., etc. So we have different possibilities, different technologies available, starting with natural-based bank filtration, for example. In Berlin, we are producing part of our drinking water by bank filtration from the river. No? So it's a natural-based system, and it's working quite well for many decades. So it's a natural system, which are not too bad. No? So we have ion exchange. I guess all of you know ion exchange. We have flocculation, precipitation. We have filtration. We have disinfection. We have membrane separation. We have distillation. We have oxidation and reduction. These are the possibilities how to pre-treat the water in order to make out of it processed water. And now we're coming to the processed water. So again, we have different water qualities which are used in industry. Now we have simple service water, we have boiler feed water, already mentioned, with a low conductivity in the range of a couple of microsiemens per centimeter. We have cooling water with certain, we have ultra pure water, we have demineralized water, drinking water for different applications, water for injection, that's for pharmaceutical industry, high quality demands, and we have softened water. So this is an examples of process water qualities which have different demands with respect to the quality, and therefore this offers opportunities. Preparation of process water requirements treatments. That's first of all, we need the treatment. That's something we have to keep in mind. This is a question of costs, capex, opex, and we have different quality demands which offers opportunities for recycled water. So to use recycled water, for example, for water for injection, it's not recommended, for sure not, in pharmaceutical industry, but you can use water very simply for service water, for cleaning cars, for example, trucks, yeah, or cleaning surfaces in the production facilities. For sure, you need certain quality requirements like no germs, no virus, no bacteria, but nevertheless, the quality is not so important. Yeah. So this offers different opportunities. This is in summary mentioned here. Different process water qualities offer the opportunity to reuse wastewater demand oriented, and what is required, intelligent water management. This is something which is the basis to apply a water management system. So looking at the organics, I give you an example, which is a picture which we can take already. This was taken in 2005, but it's the same situation nowadays. Jonas knows the picture. It's made in Tunisia. These are trucks here, and this is an open pond, and the trucks are discharging effluent into this open pond. This happens always from October to January, February, every year. You can see it also on Google Earth. What it was is large evaporation ponds, which only partly work the evaporation because you have oily content of this wastewater, and this wastewater is coming from olive oil production. Now that's the olive oil residual material which is discharged into the open ponds. So, and but nevertheless, it's highly polluting the environment. It's smelling. Yeah, smelling is a friendly word, I would say. It contains high concentrations of COD in the range of 100 grams per liter. So highly contaminating the environment. For sure, these open ponds are not sealed. So the part of the olive mill effluent is entering into the groundwater, and groundwater is also a scarce resource. So, but nevertheless, what I would like to highlight is that even in this wastewater, in this effluent, we have high concentration of valuables. In this case, are the polyphenols, 1 to 3.5 kilograms hydroxytyrosol per cubic meter of effluent, which is quite high. In a high purity, and you can easily calculate, it's 50 euros per gram, so it's a high value which is contained in these effluents. But nevertheless, this is a price for high purity, frankly speaking. So to generate this purity out of this effluent, it's more or less not feasible, I would say. But nevertheless, it has a value, and we are operating a plant, a containerized plant nowadays here in this region. It's in the middle of Tunisia, in order to treat the effluent in such a way that the polyphenols can be recovered on the one hand side. Additionally, the polyphenols, they are natural-based substances. No? So olive is producing polyphenols, and therefore to eat olives in particular, but also to consume olive oil is healthy because of the polyphenols. They have antioxidative properties. Most of the antioxidative properties are present in the olives by themselves and in the water, in the effluent here. And therefore, we have high concentrations of polyphenols. And what we are doing is we are extracting it from the effluent and improving, therefore, also biodegradability of the effluents. So if you put those effluents into bioreactors, into anaerobic digestion plants, you will have not a very high performance of these bioreactors. No? So they are limited because these polyphenols are reducing the reaction velocity, and they are reducing the efficiency of those processes. So if you take up these substances out of the effluent, you have two benefits. One is you're generating a product, and the second benefit is you're improving the bioavailability. So the effluent after removal of the polyphenols is very good, anaerobically digestible, and you can easily produce out of this methane gas. So that is a clear indicator that wastewater is equal to valuables. And this you can transfer. It's an extreme example, I know. It's, but in many cases we do not have those high concentrations of high valuable substances. But nevertheless, always think about this when you're going into a project. Always think about what is the content of the COD, of the organics, or the TOC, the total organic carbon. What is the content of this carbon? Are there substances which might be of interest? And finally, they are coming out of the production, those substances. No? So they are not coming from the heavens. They're just added by humans during the industrial production. And therefore, we have to ask ourselves, it is feasible to recycle those substances additionally. I know in many cases it's not possible, it's not feasible at the moment because raw materials are quite inexpensive. That's one point. And the second point, we always have a mixture like here. You see it's dark, it's more or less black, the effluent, and it's really difficult to treat those effluents and to extract the polyphenols out of such effluents. But nevertheless, keep this in mind and ask yourself, what are the substances, the organics present in the effluents? So we have the inorganics. That means the salts. No? So in each and every effluent, we have salts. That's also a major concern, becoming a major concern in Germany, because maybe you have heard about the fish dying in the Oder River. Oder River is nearby Berlin. It's partly the border between Germany and Poland in the northeastern part of Germany. And you might have heard last summer, late summer, a huge dying of fishes in this Oder River. And the fish dying was caused by low water flow due to dryness, less rainfall, and additionally a huge discharge of salts into the Oder River. And this huge discharge of the salts is finally ending up with brackish water concentration, and this gave an algae, which is usually only present in brackish water, the opportunity to grow. And this algae is producing toxins, and these toxins finally ended up with the death of fishes, huge amounts, huge thousands of tons of fish which died last year. It's clear it was the discharge of the inorganics. It's one reason. It's not the only reason, but it's one reason. And we are more and more concerning in Germany about the salt concentration in our freshwater surface waters, like lakes, like rivers. And also our authorities are releasing permissions only if certain salt concentrations for industrial effluents are fulfilled. So therefore, our industry has to look also for the discharge of inorganics. It's obvious if a company is located at the Rhine River, like BASF, like Bayer. The Rhine River has a huge water flow. So if you add some salts, it doesn't change anything, for sure not. But if you have a small river, a very small river, and you have a huge production site, then it's causing effects to the aquatic environment. And now I'm coming back to the Water Framework Directive, which is from my point of view, it's a very intelligent approach, legislative approach, because you are looking for the water quality in the receiving water body. That's finally the most important point, what we need, not only for the environment, but also for humans, because finally we are taking the water again out of this water body. So we have unplanned reuse already implemented all around the world, also in Germany. So we're taking water from the river upstream, we're using the water, we're discharging the water after wastewater treatment into the river again, and downstream, the next city is taking again the water from the river. So we have unplanned reuse. It's already existing. It's something which we have to keep in mind. So we have these closed cycles, more or less, we already have. And this in these cycles, if generally it's not bad, no, so it's obvious, but nevertheless we have substances in these cycles which are one part of the substance are the inorganics, but we have also organics which are recalcitrant, which are very, very stable, like the pharmaceuticals. No, I think you might know diclofenac, Voltaren, which you use when you have pain, when you have hit your bones, for example, you put Voltaren on it. It's a brand which I know personally, and the substance which is helping you against the pain is diclofenac. And diclofenac is stable. It's performing, if you take it, diclofenac, it's performing all the metabolites or resulting in metabolites, but finally it's released into the effluent. Same with carbamazepine, the same with ion X-ray contrast media, which we are using to make pictures of the inner organs, no, of the body, X-ray contrast media. They're extremely stable. We can identify them with our analytics, not with our, but with the industrial analytics of Berlin Waterworks in the whole water system of Berlin, because they are extremely stable. Fortunately, they are stable. Let's say it like this. They are do not causing toxic intermediates or transformation products. But nevertheless, these are substances which are already present. And therefore, we are using those substances also to produce tap water, no? Downstream. That's what I mentioned. And inorganics play also a very important role. I will give you an example later on. Heat, we have heat energy, and I already mentioned it. It's very, so an industry is taking, for example, well water. No? Let's assume we have well water. In Germany, the well water has a temperature of, let's say, as a mean value, 12 degrees Celsius, well water temperature. The effluent beverage industry, as an example, food industry, let's say it like this, or paper industry, we have an effluent temperature of 30 degrees. So the difference between 12 and 30 is quite simple. It's 18 degrees. So you can calculate by yourself, taking the specific heat capacity of water, which is 4 point something kilojoule per kilogram and degree Kelvin. You can calculate easily how much energy is required to heat up water from 12 degrees to 30 degrees. It's a huge amount. So you can do it by yourself. And how you can identify how much water, how much energy is required to heat up water with your boiler, which you are using each and every morning for preparing your tea, for preparing your coffee, boiled water, which you have at home. Look at the power of this boiler. My boiler has a power of 1.5 kilowatt. 1.5 kilowatt to boil my water for the tea. Therefore, this is indicating that the huge amount of water, a huge amount of energy is required to heat up water. And that means, finally, water recycling is also a question of heat recycling. I know in Isfahan, in other countries where you have a hot climate, it's a different situation because you have to cool down in many applications. That's another challenge. You have to cool down the water in the processes with cooling water. In particular, steel industry, you have to get rid of a lot of heat energy. And this is something not only for steel manufacturing, also for other facilities. Define the battery limits. The limits say, well, this is a site. And then you can easily calculate how much energy the site is entering. And then you can see, or you can identify easily how much energy has to be, let's say, get rid of by cooling. Because it's a very simple balance. I am a chemical engineer. And so I know, that balances are very, very important. And this is a very easy balance you can make. Energy in, energy out. Fair. That's it. Yeah. So, and water, I already mentioned.
Excuse me,
water.
Dr. Geissen. There was one question from Mr. Farzad, I think. As you said, we can ask in the middle of your speech. One hand was shown, and he can turn on his microphone. Mr. Farzad, can you turn on your microphone and ask your question? Or can you send your text? If your microphone is not ready, you can enter your text in the general message. Okay, so I think Dr. Geissen, you can continue, and at the end we will have his question.
Yeah, keep your question in mind anyhow, but nevertheless, I can stop at any time if you have any question. This is something you have already mentioned. So the question is now how to implement the things. And that's the situation today. I think all of us know how it's working. So we are producing water for the households, for the municipalities. This wastewater is finally going into the sewage system in the best case and treated by the wastewater treatment plant and then released into the surface water bodies. Industrial processes, we have the water uptake from the nature. Must be a pre-treatment for cooling, for example, and also for the process inside industry. And some limited treatment for recycling. Partly it's happening, partly it's installed already, and then finally ending up also in an industrial wastewater plant, which could be the effluent directly released into the environment. So we call it direct discharge or indirectly discharged via the municipal wastewater treatment plant. So we have requirements here in Germany for the discharge into wastewater treatment plants, and for sure we also have requirements here for this part of the effluent which we are releasing, which could be released into the environment directly. So in most applications, I know industry is deciding whether or not it's an only indirect discharge or a direct discharge. A mixed of both usually is not taking place. So either you have this one here or you have this one. The situation today, and additionally we have a huge amount of water which is used by farmers, by agriculture, which is partly also evaporated for sure, partly going into the plants and partly released back into the environment, going back to the groundwater. And all of this is also related to the fertilizers and the biocides and etc., which are used in farming. That's something we have to keep in mind when we're talking about these water flows. So what could be the future of an integrated industrial water management? So again, we have the households here. We are moving in Germany, very clearly speaking, in particular in large cities, into sponge city concepts. I guess you might have heard about sponge cities, which are storing the water because we have a very strong runoff because everything is sealed in the city. So we have concrete surfaces, everything is sealed, and we are moving now into a way to have a better storage of the water and to use the water or to recharge the water into the groundwater. So for me personally, I built a house 9 years ago, and I was forced by the authorities in order to take the runoff from my roof and to bring it back into the groundwater. That was a must. Yeah. And those houses, older houses which do not do so, they have to pay for it. So that's a very strong trend. These are the strong trends here. And additionally, what we can see here as a trend is removal of pharmaceuticals, trace pollutants, recovery of phosphorus. It's also a very important topic. No? Phosphorus is limited, so phosphorus resources the predictions are somehow different, but as a mean value, you can say we have resources for another 100 years approximately. So then they'll end. So therefore, we have to look for phosphorus recycling, and that's implemented right now in Germany. So we can recover so as you might know, Germany is importing 100% phosphorus. I do not know the situation in Iran. You have also phosphorus resources, but I do not know the situation in Iran. So in Germany, we have to import 100%, and out of this 100%, we can recycle about 1/3 by installation here of phosphorus recycling and wastewater treatment plants. And another thing, as a trend, just for your information, in municipal wastewater, we are moving into mono-incineration. So we are incinerating the sludges. We are producing about 1.8 million tons of sludge, dry solids, per year. And this sludges fed is moving is now going into mono incineration plants, which are just only incinerating sludge. And the reason for is very simply because we would like to recover the phosphorus from the ash. So that's the point. That's the trend here. But now coming back to the industry, we have here again the pre-treatment. We're taking a small amount because we have a lot of, you can see it here, a lot of recycling processes. Small amount from the environment with the pre-treatment. We have the rainwater, which also has partly to be pre-treated. We have some periodic reuse, so that we reusing the effluent of the wastewater treatment plant, of the municipal wastewater treatment plant, for industrial applications, like it's done in Isfahan too, or started to be done. Reuse the effluent from the wastewater treatment plant for industrial processes. So pre-treatment here. Then we have internal recycling processes like they are shown here. We are extracting some valuables out of it. We are using the water after treatment, limited treatment or full treatment for other processes, because industrial sites usually have different production facilities, and one facility has other requirements than the other one, and therefore we can reuse or recycle water for different applications inside the industrial sites. That's another approach. And therefore, finally, we can end up with much less water which is required for the industrial processes. Yeah, and even the question is finally using the effluent of municipal wastewater treatment plants for irrigation. This is another challenging topic for another talk, for another workshop discussion round. Whether this is, I just came back from Morocco. I was last week in Morocco. We have a project, European funded project with Morocco, with Tunisia and Jordan. And there we're discussing for alternative water resources. And one resource is effluent of municipal wastewater treatment plants. But the Moroccan authorities and associations clearly stated that they are not willing to use effluent from municipal wastewater treatment plants for irrigation of agricultural products at the moment. No? So it's a very difficult question, because for sure this effluent contains contaminants, and yeah, these contaminants are finally ending up in the agricultural products and in the soil. So it's a very difficult question. So that's the concept. We have had a large project which is called E4Water. The homepage is still existing. You can check it in the internet. E4Water. You will find it when you're entering E4Water into the search machines. It was a huge project with 19 partners, more than 40% from industry in 9 countries. 6 industrial demonstration sites: Procter & Gamble, Total, Solvay, Dow, Kalundborg in Denmark. Project volume of 17 million euro and funding volume of 11 million euro, and it ended in 2016. Yeah, and with this, I just like to show you our approach in our team. What we did, we looked at different levels for modeling and simulation for integrated water management inside the industrial process facilities. So that's the first approach. The first level, the upper level, is the integrated urban water cycle. That means integrated water resource management, what we are doing in Isfahan also. But the next level is the process level. So we have to go to the process level, and finally then moving into the process unit level. For example, an aerobic wastewater treatment plant, for example. And if this is not sufficient, we need also to look into the fundamentals. So how does reverse osmosis, for example, work in order to have a complete modeling and simulation for this site? In the future, we can utilize this simulation as digital twins for operation. Actually, we can use it for predictions. We can simulate, we can calculate very easily different scenarios. So for example, what happens if we are taking a larger amount of water from municipal wastewater treatment plant? What happens if we are changing the products in this or that way? Or No? So you can calculate different scenarios very easily. And from my point of view, these models, the simulation models, are very essential. Maybe at the very beginning, I would not start with dynamic modeling. I would start with static modeling. It's easier, it's much faster, and it's more than sufficient starting with this. Because digital twins is another challenge. No? So therefore, you need simulation, which has to be utilized. But finally, this is really challenging. Yeah, and this is what we did for one site. It was a PVC production. A lot of information here inside, but just showing you how it looks like. And left-hand side is the raw water, well water, which is in Spain location in Spain. We have left side here is the water intake, which is then moving into the pre-treatment, different kind of pre-treatments. Then part of the water is entering into the cooling water. Now, this is a cooling water cycle. There's a huge amount of water, which is here recycled. So the width of these arrows is giving you the amount of the water. And then we have the different production sites here, or the production units. And finally, here downstream is the wastewater treatment and recycling system, just as an information. I will not go into detail, but just showing you that with the tools which we have available, it's easily, it can be not easily, but it can be managed to install such a water and energy management model. So, and it's not, as the name says, it's not only related to water, it's also related to energy. And also what we did, additionally, what we did is we utilized all the elements. Now we said, for example, magnesium, calcium. These are salts which are producing hardness, which producing scaling on top of the pipelines, the membranes, etc. Therefore, we said, well, we have to follow up also calcium and magnesium, the hardness builders. Yeah, and this is something which you already know. This is Sayed root basin. Maybe a 30 large industry. Maybe it's a little bit boring for you. I will give you all the slides. You can go deeper inside. There's a lot of publications available, but I think this is something which you already know. So what you might not know is we have many information resources available. They are for free. So I just like to introduce to you only one position paper. I am also head of a working group inside DECHEMA. DECHEMA is a large association of the process industry, and companies like BASF, Bayer, Covestro, they are members of this DECHEMA association. And within this working group or specialist group, we release several studies. One study is Trends and Perspectives in Industrial Water Technology 2030. Which is in English available now. You can download it for free, but we have others which are dealing, for example, with zero liquid discharge. Is zero liquid discharge a sustainable solution or not? So all of these informations are for free. And there are experts from industry, experts from universities, and research institutions that cooperate in order to generate such position papers. Yeah. Only one example, we have many of them, and you can download them for free, as I mentioned already. This is an example here, the position paper, the methodology. We looked for the mega trends and global conditions in generally for 2030, the state of the art, the requirements and development and the targets. Out of this, we developed the fields of action, definition of fields and challenges, and then the implementation, derivation of research and development demand, and the roadmap to realization. And this finally should end up in industrial integrated sustainable industrial water management. Another paper which I just like to mention in addition, maybe Masoud can give you also the link finally at the end of the day, but maybe you've heard about this, Masoud, the Prof documents, best reference documents. Masoud, have you heard about this? The Profs?
No, I have not heard about it. document?
It's a very, very good, I would say, one of the best documents I know. Again, they are for free. You can download them, enter in the search machines BREF, B-R-E-F, and Sevilla, the Spanish city, or Europe, or whatever, and then you will get a link to press for each and every industries. So steel, paper, these are documents which are containing, let's say, which have a size of about 400 pages or so, each and every document, which is describing the different kind of processes which are used for the industrial process, which are also addressing waste, which are addressing gas emissions, which are addressing wastewater and wastewater treatment. Everything is described inside all these BREFs. So therefore, it's also a very good database, yeah, for you to get more information about the different industrial processes. So if I would enter into a new process, which I do not know, so if I would have been asked for consulting for, let's say, certain industry and I have no clue about this industry, I would first of all download this document for this industry, class industry or whatever, and read it and inform myself about the industrial processes, which are, let's say, state of the art in this field. This is an additional, recommendation, let's say it like this. Yeah, how to implement? Very, very important. So we made a lot of experience in Germany, or with German money, let's say it like this, outside Germany, the assistance to, let's say, developing countries. We invested a lot into environmental protection, but finally what we saw in the past is always that the plants are running after installation for a certain while, and then they are stopping. Why? Because people are not trained. They have no spare parts. No, they are not motivated. So we are now on the way to identify better ways for implementation of technologies which are reducing the environmental pollution. And this is containing the awareness, the education, the training, and the competitiveness. So it's very, very essential. And this takes generations, frankly speaking. The best way from my point of view is to start in the kindergarten, always, to increase awareness. It's the best way to start. Enhancing the transfer of research and development knowledge to innovation. I think that's all around the same. All universities are addressing this all around the world with innovation centers, entrepreneur centers, etc., etc. But it's difficult. It's really challenging. Also in Germany, it's challenging. No? But we have to work on this. Fundamentals, scale up, demonstration, application. I was involved in some technologies which have been implemented finally into a full scale. For example, for POSCO steel, it's now a huge plant for aerobics treatment of effluent from steel industry. POSCO is now a very huge project. But frankly speaking, from the first idea, starting with the idea, to the first full-scale plant, it took 10 years minimum, maybe 11 years or so. So a long time which is required. A lot of workload, a lot of problems or challenges, I would call it challenges, a lot of challenges related to this. So it's not easy. And if you are thinking about to become an entrepreneur, the most important thing is continue. And continue. Never stop. Yeah, continue. That's the most important word which you have to keep in mind when you're moving into entrepreneur as an entrepreneur. Yeah, but nevertheless, it's challenging. I like it very much. It's very interesting. Fundamentals, scale up, demonstration, and then finally the application. You have always challenges in between the scale up. And so, for example, if you're looking at the bioreactor, usually we are working with a height of 1 meter approximately, and we are scaling up to 10 meters. So it's a difference in pressure between 0.1 and 1 bar at the bottom of the reactor. No? So just the pressure. That means the gas solubility is completely different. This is one example of many, many other examples which are of importance when you're thinking about or when you are dealing with scale up. No? So it's not easy, but it's possible. And it's, from my point of view, it's really interesting. We need demonstration platforms where we can test new things. No? So I think that's also valid for Iran, that you have to have a certain, let's say, mentality to implement new things, to try new things. Yeah, just trying it, no? and cooperating with universities, with researchers in order to do so. Therefore, we need platforms. In Germany, it's more difficult because we need a lot of, I guess the same in Iran, the same in other countries. We need a lot of, let's say, to fulfill many regulations, a lot of permissions we need in order to implement or to perform a scale up of a plant. Yeah, eco-efficient water management turns into production integrated. So we have to move into the production by themselves. I know it's difficult because it's also a question of intellectual properties. It's a question of competition. No, you would not like to give all the information of your production to other people. So therefore, legally, it's a question of NDAs, non-disclosure agreements, which you need, and frankly, finally, to speak about trust. That's the most important thing. You have to have trust when you're cooperating with externals, with consultants who are looking into your production in order to improve the production. And this is something which has to be done. Maybe not tomorrow, but the day after tomorrow. Artificial intelligence is coming. It's clear. So we have all the tools available. In municipal wastewater treatment, I would say it takes more time than industrial wastewater because industry is driven by improving the efficiency, and we call it 4.0, Industry 4.0. Is indicating the artificial intelligence implemented into industrial production processes. But it's the same in wastewater treatment and wastewater management. As I showed you, we have also projects in industry where we're looking at large sites, and it's coming. It's a question when you would like to implement. But we have the tools, we have the knowledge in order to do so, and it's only the question, as I mentioned, when. Yeah, and we need an LCA finally implemented for each and everything what we are doing, LCA and LCC, also life cycle assessment and life cycle costing. It's always better than directly implementing zero liquid discharge, because it's first of all, you should start with an evaluation of different scenarios in order to assess whether or not zero liquid discharge should be really applied. Because it's highly energy intensive, or it's energy intensive, let's say it like this, and it requires, let's say, a good evaluation whether to do so or not. But what is important? Life cycle costing. So for me, as a company, it would be not interesting the capex, the capital costs. For me, it would be more important what will be the life cycle costing. So what are the costs of the spare parts? What are the service intervals? And last but not least, what is about the service? Is there service available? When will be, for example, if I purchase a pump, for me, very interesting would be how fast I get the spare parts, how fast I get the service. That's mostly more important because you're losing production time when the pump is not running, maybe. So therefore, this is coming. It's obvious, must come. Yeah, recycling of water, valuables, and utilization of energy has to be taken into account. That's already mentioned by me earlier. So we have some trends. Motivations are, besides the economics, for sure, it's always economics, but we have the green labeling. Many products can be not sold. So we have the trend in MENA. In the MENA countries, I have had a talk last October to some industrial companies. And I asked them why are they interested in wastewater treatment? Because there is no need for it, and they told me, yes, we have to do so because our customers are in Europe. And and they are asking for our wastewater treatment stuff. They are asking us for our waste management. They're asking us for our gas emissions. So all this is driven by the consumers finally in Europe or wherever all around the world. This is a strong trend. You need green labeling. Independency, I already mentioned, and recovery of valuables, for sure, if you have highly valuables, because finally you're adding the substance to the wastewater. So you have to purchase the substances before you're adding them into the water, and they're ending up as wastewater. So you have to pay for them twice, let's say this is. First, when you're purchasing them, and secondly, when you're treating the effluent in order to get rid of them. So therefore, you have to ask the question, are there substances which have a certain value? Yeah, reduction of water demand, major application in third countries. It's a matter of fact, you can do a lot. Then recycling. What I didn't mention so far is a concentrate processing. We are working on this topic since 2014. What is, when you are recycling water, a membrane is very simple. No? A reverse osmosis is very simple. It's cutting one flow into two flows. One permeate, which has a high quality, and the second flow is a concentrate, which contains all the rejected substances, all the organics, all the heavy metals, all the salts. What to do with the concentrates finally? That's the question. And there we're working on this question for brackish water desalination. We're looking at for industrial water recycling. We're looking for drinking water production. We have in Germany about 90 membrane-based drinking water production facilities, 90. And all of them are producing concentrates. What to do with the concentrates? That's a very important question for the next, I would say, 15, 20 years. And also desalination plants, the same. No? If you are looking at the seawater desalination plants, the huge ones, 300,000, 400,000, 500,000 cubic meters per day, they're producing the same amount of concentrate, which is usually discharged back into the sea. And if you're looking at the Persian Gulf, for example, my predictions are not very good, no? Making a balance around the Persian Gulf. Because not only you, but not only Iran, but basically Saudi Arabia is discharging a lot of brines into the, and you have a high evaporation. No? And so the question, low intake of fresh water, of rainwater into the Persian Gulf. So these are questions which have to be answered in the future. Recovery of valuables and heat, I already mentioned, and then management, digitalization, we have smart grids, modeling and simulation. So digitalization, the measurement equipment became quite cheap. Now, so flow meters and temperature measurement is not highly costly. So therefore you can purchase those measurement equipment, the simple ones for low cost, and implementing into the SCADA system. But again, nowadays, moving into the digital twin things that you have a complete digital twin. And I know it from, for me, a good example is, again, the steel factories. So those of you who are from the steel industry, you might know SMS Group, which is one of the largest companies worldwide, producing steel factories. And they have, when they are designing a plant, building a plant, a steel factory, complete plant, they have the complete plant digital available. The training of the personnel starts in Germany with a digital twin of the complete steel plant. I saw it. I was really impressed about this. And in wastewater treatment, we're far away from this, but we are moving into this digital twins, and not only to train people, but also to improve the performance of the plants, and also to predict what happens if we have a strong, large flow via flooding, for example. What happens if we have extreme conditions, extreme temperatures, for example. This is something which can be answered with digital twins. Yeah, this is my team. We are very international. It's an older picture, unfortunately, but nevertheless, still more or less the same international team. So we have had also a colleague from Iran in my team for a certain while, but usually we are very international PhD candidates in my team. And for those of you who are students, so I'm embedded into the Institute of Environmental Technology. These are bachelor and master courses, environmental technologies. One of the oldest courses worldwide. It was started in 1976, environmental technology at Technical University of Berlin. And 6 chairs are basically responsible for the education. Out of this is my chair is one of those 6 chairs. And we have about 100 students starting each and every year. And finally, 60 are ending up with a master degree at the very end. Yeah, thank you very much for the attention. And yeah, we can discuss as you like. And if you have questions or remarks, comments, please yeah, start.
Thank you, Prof. Geissen, for your nice presentation and informative lecture you gave us. One of the correspondents from a news agency asked me to give a brief presentation of your lecture in Persian. So if the correspondent is present at the session, I give a short, brief, short summary of your presentation in Farsi. آقای پروفسور گایزن در مورد بحث مدیریت به اصطلاح آبای صنعتی اشاره کردن به بحث ساستینبیلیتی، پایداری و در واقع اهمیت مصارف آب توی صنایع که تاکید کردند در واقع نه تنها بحث‌های تکنولوژی بلکه بحث‌های مدیریتی و لوجستیک هم در مدیریت مصرف آب در صنایع اهمیت داره و در واقع بحث‌های مثال‌هایی را از صنایع کاغذ، صنایع تولید زیتون یا صنایع فولاد و نیروگاه زدند که به شیوه‌های مختلف از جنبه مدیریتی و هم تکنولوژیک بتونن در واقع مواد عالی یا ترکیبات معدنی یا به اصطلاح حتی گرما رو چجوری در واقع بتونن از برجای خنک کننده بازیافت کنن و این رو به چرخه مصرف بیارن. در واقع همون بحث پایداری و مفهوم اقتصاد چرخشی هست که در واقع در صنایع باید پیاده سازی بشه. بحث بازیافت فسفر رو در واقع از با سوزاندن لجن توی تصفیه فاضلاب اشاره کردن و اشاره هم به کاربرد مدل‌های شبیه سازی توی تحلیل سناریو و ارزیابی جنبه‌های مختلف کردن و در واقع بحث مدیریت یک پارچه منابع آب رو در واقع در همین راستا ایشون ذکر کردن و در واقع یکی از معضلاتی هم که در پایان صحبتشون اشاره کردن بحث تخلیه آب شور به دریاها بود که مورد دریای خلیج فارس رو ذکر کردن که با توجه به که ایران و کشورهای خلیج فارس این سالیان سال این تخلیه آب شور داره انجام میشه، پیش بینی شرایط آینده خلیج فارس به هر حال یه مقداری مشکل هست و امیدواریم شرایط رو به بدتری نباشه. من تشکر میکنم. Thank you, Dr. Geissen. I give a brief summary of your presentation and we are ready for the question. Mr. Fardad is ready to ask his question. Mr. Farzad, if you can turn on your microphone, you can ask.
Yes. Hello, and thank you for your useful presentation, Doctor. Can you hear me?
Yes, very clearly.
Okay. I'm a chemical engineer from Environment Department Protection from a Morocco Steel Company, the biggest steel maker in Middle East and the north of Africa. Okay.
I know your company very well.
Yes, and we are next to Zayandrud River, and we have many measures to reduce the use of our raw water from the Zayandrud. And at the moment, we use only less than 1% of Zayandrud water. Okay, and I think the most important problem in Iran about water is not the industries; it's about the irrigation. You know, because only 2 or 3% of water in Iran is used in industries, and about 90% is used in irrigation. And Morocco company is now, I can say, it's the pioneer of water reduction use in industry, in steel industries, in all around the world. We have had many measures to control our water use, and for example, we have about the wastewater from near cities, and we treat it in our company and use it again. and we recycle water 7 or 8 times. And our next step to reduce our raw water from Zayandrud River is to use Oman Sea water, okay, not Persian Gulf. It's Oman Sea, as you know, it's near Indian Ocean, and the salt, I think it won't have the problems won't make problem like the problems we have in the Gulf, Persian Gulf. Okay, and when we start the project with our use of raw material from Zayandrud River will be 0. And as I said, the biggest problem in water use is in irrigation in Iran. Thank you for your notation.
Yeah, this was a comment. I know. As I mentioned, we visited. I think I personally visited Mubarak twice, and I know during this 5 years ago or so. And I know that you installed a lot of reverse osmosis plants, for example, for water recycling, and also your ponds, which you have for. So I know, but I do not remember all the details. Frankly speaking, I do not know the trends. Would be very interesting, maybe via Masoud, to learn more about these trends, what you have done so far, and what you are planning to do. Finally, Oman, for sure, it's open. It's the Indian Ocean. You are open, but nevertheless, locally, the discharge of the brines will result in with the same problems. No, it's depending on the site for sure. Depending on the currents which we have for discharge of the brines. But my statement was not related to, let's say, to Persian Gulf. It's also related to the Gulf of Suez, for example. No, or Gulf Aqaba, Jordan, and these huge projects which are not initiated. So I've heard about the project that you are taking water from Oman, but I would like to learn more about this because this is very important. We have the same situation in Jordan. You might have heard about the Red Sea, Dead Sea project. They're taking the water from Aqaba, desalination plant, up to Amman, and then they are using the water, then they are treating the water and they're discharging it to the Dead Sea. It's a huge project. The same in Libya. Libya, the man-made river, will be reactivated. So we have many, many projects all around the world which are transporting a lot of water, which has a strong impact, let's say finally, maybe not tomorrow, but maybe in 10 years, no? On the local conditions. So this is something which has to be evaluated. I would not say, so for sure, it's better to take the water from the Gulf of Oman than the Persian Gulf, that's for sure. But it has to be evaluated. No? That's my statement.
And as you know, Spain is the biggest, has the biggest plans of desalting water from the, I think, Mediterranean Sea. And what is the European management about this water use? And is it going to be stopped or not?
No. That's the point. So we have to differentiate. So I'm member of the university. I can look, as Masoud is also doing so. We are looking into, in Hamid, we are looking 5 years, 10 years in the future. That's our approach. You as industry, you should look maybe a couple of years in the future. But we are looking at the medium to long-term perspectives. No? So therefore, we have to be careful while comparing both statements. No? So your statement is clear. My statement is also clear. My statement is for 5, 10, 15 years in the future. No? So it's a different approach. But nevertheless, we can identify when you're looking at the world scale, a huge amount of desalination plants are built. No? Still built. 300,000, 400,000, 500 cubic meter per day. This is a standard size. Meanwhile, all around the world. And this is what I'm concerned about is, and what we can see in the discussions with the worldwide experts is, we are concerned about the brines. We are concerned about the chemicals which are used, so the antiscalants, which are partly also passing through the permeate. We are finishing a drinking water project on reverse osmosis, we have identified that the antiscalants are passing through the membrane, and that the antiscalants also have ecotoxicological function. So is it something which is for you from industry at the moment not important? For you, it's the balance, the cost. No? For example, transporting water from the Gulf of Oman after desalination. So in the best case, you have low energy prices in Iran. You pay maybe $1 or so, even less per cubic meter, and then you have the transportation and you have the storage. No? So again, therefore, is integrated water resource management very important. And you're completely right. No? So no one is, and even no, I don't say anything about agriculture. Agriculture worldwide, not only Iran, worldwide is the hugest water consumer. And we are working on this. No? So the societies all around the world are working on this to reduce the water demand for agriculture. But finally, we need food. No? And then if there's no water, the question, who gets the water? We are the same with energy. In Germany, we have had the discussion starting with the war. What happens with the energy? Who gets energy? Is industry first? Or is the households first? Who gets the energy? Yeah, this energy, if you have a lack of a certain good, the society starts a discussion who gets the energy, who gets the water or whatever. No? So that's something we have to keep in mind. But it's clear. No? So we have to work on this. And there's also a huge potential. I didn't address this, for sure not, but I know there's a huge potential to reduce water for irrigation. There's a lot of water wasted, for sure.
Yes.
It's 100%.
Yeah, thank you.
Thank you.
Mr. Farsad, we're very much interested in a contact to you. So via or Hamid or whomever, please, if you are interested in, we can stay in contact, no? Because we are financed by our ministry, and we can look for you in the future, in the let's say longer lasting future, 5 to 10 years.
Sure.
Yeah.
Sure.
Okay.
You can
But it's up to
send
you.
your email, your phone number
Yes.
in my private, so we will be in contact with you.
Yes. Sure.
Thank you.
Sure. Thank you.
I see Mr. Jawad Agha Kishizadeh. Mr. Agha Kishi, do you have a question? Can you start your microphone? Also, Mr. Yunus had a question. I'm not sure. Maybe Yunus can ask his question now, and then Mr. Agha Kishi.
I just wanted to have a comment about the irrigation aspect, because we are doing this in the frame of IWRM, Integrated Water Resource Management in the Science route. And as TU Berlin, we are just looking at the industrial partners, and there has been a long cooperation with Isfahan, Isfahan Steel Company, ESCO, Mubarakeh, the power plant, so the large water consumers, especially cooling water. So this is the part that TU Berlin is looking at, but we have people looking at the natural systems, modeling the groundwater and the surface water, and also, of course, looking at the irrigation and water consumption from agriculture, which is a very important point. But as TU Berlin, we focus on the industrial water consumption, and we have to say, from a water perspective, Isfahan produces some of the most efficient steel in the world. So it's nice to see that there is a lot of willingness for investment in regards to water efficiency.
Thank you, Yunus. And we hope that we can see you in Iran in next month, if it is possible and no problem happens. And we can have a presentation here for you and some visits to proceed the collaboration. Also, Mr. Farzad has sent his phone number, and Mr. Taebi has asked a question about an industry of sand and gravel. They have a sand and gravel industry, and they have a wastewater that is produced from, they produce glucose from starch. They have problem. He asks that they have problem with their sludge that produces and generate worms in the sludge that they cannot be removed. He asked how can they remove the organic pollutants? Do you have any suggestion for him?
Yeah, it's always difficult to answer those questions because we need, as you know, much more details. But
yes,
generally speaking, sludge is which is generated by wastewater treatment. It doesn't matter whether it's or from municipal wastewater treatment or from industrial wastewater treatment. It's a challenge. So usually, depending on the size, I'm always recommending to install an anaerobic digestion, but it's a question of price. It's expensive, but minimum stabilization. You can do it aerobically, as energy is quite inexpensive in Iran. You can do it also aerobically. So basically, I would estimate, but this is just an estimation, that reducing the organics by a biological treatment would be the best way to prevent the growth of the worms. But again, we need more information, and the same, contact my colleagues in Iran, and then we can initiate a meeting. So I'm open for this. So my intention is to help to protect the environment. So I would not, I'm not interested in earning money, just protecting the environment, no? All around the world. That's my aim, finally. So therefore, I'm open. And if you like to, you can contact my colleagues and we can initiate an online meeting. My team member, Jonas Pluschke, might be in 1 month in Iran. He can meet you also personally if necessary. So if we get the data, we can give you a recommendation.
Thank you for your warm reception. Yes, Mr. Taebi, you understand that you can. And Mr. Jawad Agha Kishi has asked how he can contact Professor Geissen. There is a his website is available, and you can send him email. If you search his name on the Google, you can find his web address and his email. Mr. Alipur, Rasul Alipur, can you ask by microphone, or do you want to send the text of your question? Mr. Alipur is writing, yes. Yes, you can. Do you have, you should activate your microphone when you enter the room. Have you activated it? I'm not sure about your activation, Mr.
Hello, do you have my voice?
Yes, yes, you can ask your question.
Hello, Dr. Tahirun and Professor Geissen. Thank you very much for organizing this informative webinar for us. It was really informative and good for me, at least. I'm Rasul Alipur at Shahrikord University, approximately in the middle of Iran, Professor. 1 hour time by car near Isfahan city. We have a problem in this city, actually, after this kind of climate change and monsoon raining. The source of drinking water in the network of the city have encouraged with the problem. The turbidity of Kuhrang Spring, which is actually located in the sinkhole, karstic sinkhole, have been increased highly, dramatically increased. And for example, the standard for NTU of turbidity of water in good condition is below than 1. but in some cases it increased near 4,000. Or after spring, or by melting the snow, this will change, even reach to 200 NTU. I wanted to ask if you have any, do your experience and knowledge, do you have any case study around the world that by this phenomena, the turbidity of water increased drastically? And the second question, how we can manage and deal with this problem? Thank you very much.
Yeah, frankly speaking, I'm no expert in this field, but I have learned during from my colleagues from hydrogeology a lot, or a little bit knowledge on this. Karst is a special formation, and the rejection of solids is quite poor. But I highly recommend to contact, maybe if you, the same like for the questions before, if you contact Masoud or Hamid and giving your information, and what I can do, what I promise to do, is I will forward your contact details to my colleague from hydrogeology, Uwe Tröger. You can Google it, Professor Tröger. Maybe Jonas, you can write it in the chat meanwhile. His email address. No, it's not. No, I have to be careful because he's retired. Therefore, he has some time, and but he has a private email address now. So therefore, send a message to my colleagues, and they will forward it to me or send it directly to me, and I will get in touch. We'll bring you in touch with Uwe Tröger, with my colleague Uwe Tröger.
Yes, I know Dr. Alipur is a faculty member of Shahrekord University, and is now the head of the technical office of the university, and is dealing with the civil projects in the university. And he mentions the problem that last year was happened in for the water of city of Shahrekord, and the water source, their water resource was polluted by high turbidity, and for many days, I think 3 or 4 weeks, the city did not have water because of the high turbidity, and it hadn't happened before. It was I think the first time, as I know. So it is a very problem that they prevent it in future if it happens. So I have his contact number, and I will connect to you for further collaboration, further discussion. Thank you. And also, if there is any other question, we can answer that. Yes, thank you, Mr. Dr. Alipur. Okay, I think there is no further question. Mr. Rahimi, I saw that he had many questions. So we have different participants from the university, industry, and different universities. Also, I'm pleased to see that the students from Berlin University are present, and we hope that such sessions, such meetings will continue further, and we can share our information, our lectures together, and discuss for a better future of water management. Thank you very much, Professor Geissen. Do you have any final comments?
No, I just like to say thank you again, in particular also for this interesting discussion. For me, it's very important because not many information from Iran are coming or are available. Therefore, and again, I like to mention we have only one Earth, no? So, and we as researchers and developers, we should work on the protection of the environment to develop scenarios where, society can live safely and also our grandchildren can do so. And hopefully they have the same environment as we have or as our parents have had. That's my personal aim. So thank you very much, in particular for this moderation and this very professional preparation and also organization of this event. I'm very much impressed about it, and saying thank you to all of you joining this discussion and
Thank you very much.
presentation, and hopefully see you. Bye-bye.
Thank you
Thank
so
you.
much, and goodbye to everybody. Thank for all the audience to come with us, and goodbye all. Thank you very much. Goodbye. Bye bye.
Goodbye.